This is Professor D. I have a short video on regression equations, and this is the last section that we cover in Math 152. This is a PowerPoint I created a couple of years ago for a class, so it's a little bit different from what you might see in the book, but this is material that I feel is important and will be covered on the group project. Okay. Again, here's a table of contents which will take you through all the stuff you need to know, and you can click on any of these things that are in yellow and get to the specific section, and if you click on the TOC button in the bottom right corner, it'll take you back to this screen. And learning objectives is reviewing basic linear equations. Chapter 7 is rearing its ugly head again. Forms of linear equations, slope, talking about correlation, doing scatter plots in Excel, and determining regression equations in Excel. So basic linear equation has the form y equals mx plus b. M is your slope, b is your y-intercept. Different forms of linear equations. Sometimes you'll hear it called line of best fit, and different formulas will convey the same information. But in statistics, you might see b naught x plus b1. b naught is your slope. Sometimes you might see it as b plus mx. They just reverse the order. This little y hat, this looks like a little carrot or hat on top, that's the predicted value of y based on the data. Sometimes you see as ax plus b. Just keep in mind that anything that's attached to your x is your slope, and any number that's by itself is your y-intercept. Review of slope. Slope is just, here's a positive slope. That's telling you that your line, as your x is getting bigger, your y is getting bigger. Negative slope, as your x is getting bigger, your y is getting smaller. Correlation tells you about the relationship between two variables. Strong linear correlation is right here. There's a very strong linear relationship between the two variables. As x gets bigger, y gets bigger. No linear correlation, it's just kind of big jumbled mess. And here's weak linear correlation. Well, x is getting bigger, y is getting bigger, but it's not really in a nice tight line. That's weak linear correlation. Okay. Scatter plot. X is your independent, or it's also called your exploratory variable. Y is your dependent or your response variable. And here's just sort of a graphic of how a scatter plot would work. Price in dollars versus number of bids. So eBay example, price in dollars versus the number of bids that it gets. So you can see as the price in dollar is higher, the number of bids is increasing. Okay. How do you find the line of best fit? So this is taking you through the steps. What you do is you would first get your data points into Excel, right-click, add trend line. Then you click on linear, display equation on chart, close, and it'll display your equation on the chart. Here our slope is 0.2299x minus 1.7356. So as x increases by 1, y is increasing by 0.229x. So a $1 increase in the price in dollars is increasing the bids by about 0.23. Okay, and it's not really, you can't really talk about the y-intercept here because it's less than 0. So you really can't make any judgments about this y-intercept. Okay, here's a nice YouTube video. If you click on this, it'll take you out to a Excel video, about how to find the line of best fit on YouTube. So it'll take you step by step through finding that. And here's an example, the unsupervised student. Does the number of hours a high school student spends unsupervised impact their overall grade average? So the number of hours they spend unsupervised or overall grade average. First thing you do is you plot that in Excel. So it kind of looks like that. And what I'm going to do, I'm actually going to go through doing it. So let me get out of here. See if I can just copy this so I don't have to write it over. I'll be a little bit lazy. Let me pull up Excel. into this text. Okay, so I've pasted this into Excel, and I'm going to show you how to do this. Let's make the zoom a little bit bigger because I know your screen is small. Okay, so here's my X, here's my Y. Highlight that, insert, scatter, and look what it did for me. Made me a scatter plot. Here's my X, here's my Y. I want to change the formatting it because I want to be able to put in different things so you can play with it. What I did here is I'm on the design screen. Here, let's go back. So I'm in the home screen. First thing I did is I highlighted. I went to insert, scatter, chose the first one. It looks like this, but I can't put nice titles and labels here. So it puts me on this design screen, and then I have all these different choices for design. Let's start with this first one. So let's put an access title in. Now, the first thing is, because I only have one set of data, and you're going to do 2 scatter plots, so you're only going to have one set of data on each, you do not need this key. And then I can take that out, and it's going to make it a little bit bigger. So this access title is going to be my X, or my hours unsupervised. That's also my X, if I could type correctly. This access title is my overall grade average, or my Y. My shift key does not like me today. Okay, and I want to call this overall grade average versus hours unsupervised. Okay, like that. All right, I got everything. And now I click on my data points. See how when I click, it makes everything highlighted. I'm going to right click. I click Add Trend Line, Linear, Display Equation on Chart, Display R-squared value on chart. That's my correlation coefficient. Well, actually, that's my coefficient of variation, not my correlation coefficient. I don't want to do that. You guys need to do the correlation coefficient. And there it is. How cool is that? So the other thing you guys need to do, which is not in this PowerPoint, is the correlation coefficient. So there's a function in Excel. Correlation. So I expect this to have some sort of negative correlation because it looks like it has pretty strong, if you look at this regression line, it goes through a lot of these points. And then your R value, your correlation coefficient, is going to go between -1 and 1. The closer it is to -1, the more perfect negative linear correlation it has. If it's -1, it has perfect negative linear correlation, which means as X gets bigger, Y gets smaller. Closer it is, R is to 0, it means it has no correlation. And the closer R is to +1, it means it has perfect positive linear correlation. But luckily for us, Excel has a function called correlation. So if I look up if I type in the word correlation, there's a function called coral. So I want to do array 1, and I can just go here and hit enter, hit array 2, enter, say OK, and there's my correlation coefficient, my R value, -0.97, which is what I thought because it was really close to -1. That is what you have to do once you get all your data points, guys, for your project. I'm making it kind of easy for you. I'm trying to make it kind of easy for you. So here you go, and this coming back here, this kind of just doing the exact same thing. So our slope was negative 4.1. So it's saying, what's going on here? It's saying that GPAs start about 86, right? We can interpret the y-intercept here because it's positive. So it's saying that your GPA starts about at 86, but for every hour you're unsupervised, your GPA goes down by about 4 points. Interesting, huh? Every hour unsupervised, your GPA is going to go down by about 4 points. Okay, well hopefully that's enough to get you started. Good luck, and I will see you all online.